Hello, everyone. Welcome back to the 1X Developer Podcast. It's been a while. I'm Colin.
I'm Brendan.
How's it going, Brendan?
It's going good, man. Yeah.
Good?
We took
Yeah.
took a little time off, but how are you doing?
I'm good. I did say I did want to mention that our subscriber base has held pretty steady. I think maybe we lost like one guy.
That's because everyone who is subscribed is a true believer.
Yeah, we got a dedicated fan base.
Yeah, no, I saw that too. I checked on it. And I was like, nice. People aren't giving up on us.
Yeah. Well, I don't know about you, but I'm subscribed to stuff that I forgot about. Like, there's dead channels I'm subscribed to.
Oh yeah. I never go through and like prune my subscriptions.
Yeah, I'd only unsubscribe if somebody like actually starts to be annoying. Really, if they're like uploading a lot and their content is just like, usually I unsubscribe because their content's all the same stuff all the time. That's the usual thing that happens.
Yeah. Yeah. Most of the channels I'm subscribed to, I would never even know it if they stop posting.
But you guys would know when we stop posting.
Our number one fan, my friend Audra, she did ask where we were.
Oh, let's go. Okay.
She was like, "What's going on? What are you guys doing?"
None of my friends asked me, so I'm pretty sure none of them were listening.
Well, they can cram it. Dead to me.
Well, they're still subscribed, I think. So,
all right, I take it back.
Okay. Brendan, what do you got? What do you got for us? You got some Godot stuff?
Yeah. So in the past few months, I've been messing around with Godot. So let me just a little bit of backstory here. A lot of the stuff that I try to do, like in my hobby projects and stuff, is related to like generating visuals that are connected to audio, basically. Mm-hmm. So like, that's just kind of a fun thing I've been messing around with for the last few years. And usually that means making some kind of like music video or something like that, where the visuals are like in sync with the music. But I kind of had this revelation a few years ago where I was like, these things that I'm doing are very, very similar to like video game creation, right? A lot of the same techniques. You need to be generating visuals extremely quickly. You need to be responding to input. Like in the case of the stuff I'm doing, that's usually either a MIDI controller or, the audio data itself. You're generating visuals in response to that. But, in a video game, the input is the controller and all that. But like, apart from that, they're very, very similar things. And so I've always kind of wondered, I wonder if I could use a game engine to generate some of these visuals, and people definitely do that. So that's something that's been kicking around in my mind for the past few years. And I was like, Unity or Unreal or Godot or whatever. So I finally took the plunge and tried to learn a little about Godot. And this is kind of like, I just want to stress that this is like my very first Godot project. This is the first thing that I'm trying to do. Don't look at my code and be like, this guy doesn't know what he's doing. I know I don't know what I'm doing. So it's just me messing around trying to learn about Godot. But I did have trouble when I was looking for stuff about like how to make Godot programs that respond to audio. I did have trouble kind of like finding all the information in one place. So I kind of wanted to go through that and just give a quick tutorial about kind of how to do that.
Yeah, I mean, I've messed with Godot a little bit, doing game dev stuff, but I've never gotten into really audio stuff like that. So that'll be interesting.
There's a couple different ways to do audio, so there's some options. All right. This tutorial is all about my wizard.
Did you draw all these assets we're seeing here?
I did.
Let's go.
I did that brick wall all by myself.
Hell yeah, dude.
So you can see here that he's responding to the sound of my voice, which is kind of cool.
Yeah, that is cool. Doesn't respond to me. No.
Nope. It's responding to my microphone only. Pop, 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 pop. But yeah, I drew this. These are these goofy little cartoons I do. I'll do them for like birthday cards and stuff like that for people. But
Dude, we should have this waveform thing you've got going on in the beam. Like, we should do that every episode. That should be we should just have that going.
Just like overlaid on our video?
Yeah. I remember I looked into something like that briefly before when we were just an audio podcast. Like, what if we had like a little waveform thing? But I gave up because it's like, whatever.
But that'd be cool. I watch a lot of kind of like I was talking about, music videos or whatever. I watch a bunch of like people who post DJ mixes, and they'll have something like that.
Yeah.
So this is my wizard. Again, I don't really know what I'm doing, but this is basically just a bunch of different sprites that are kind of like moving around. There are a few controls where I can control like, let's see. He's got like, I can like speed up his hands.
Oh yeah.
Speed up his hands. Oh, I guess that's his head, but yeah.
So did you do this animation using like the like built-in like Godot animator thing where you kind of like set I forget all the terms, but you know what I mean? Like you kind of set one position and then set another one and then like transition them.
Yep, exactly.
Yeah, cool.
Yeah, so these are all just sprites that I moved around and set. So yeah, the node is called animation player, I think, and then you set a keyframes for each node.
Okay. By the way, I can't see whatever overlay you have. I just see the wizard. If you're
just
trying
the wizard,
yeah.
That's okay for now. Let's focus on the wizard, and then we'll move to. I'll show some of the other parameters when we get into the code.
Cool.
But first, I just want to show. Let's just like have some fun with the wizard first.
Yeah.
So. Yeah, so there's a couple different things going on here in terms of like how he's responding to the audio. The first is, yeah, you can see that the beam coming out of his magic ball there is like what you would typically think of when you think of a waveform. So that's like basically bass on the left and then higher frequencies as it moves to the right. And you can see that like... I'll turn that up a little.
Oh yeah.
So that's just kind of like the entire, the entire spectrum of audio. That's all the frequencies. And then you can kind of see the magic ball has this little like light source that's getting bigger and smaller. That's like that's responding only to the bass. So like,
whoa. When you say only the bass, do you just mean like below a certain frequency, or?
So yeah, I defined a frequency range. Right now it is. Let's see what we got. Right now it's between 50 and 200 hertz.
50 and 200, yeah, that's what I thought.
So, so it's only listening to the bass stuff. I have a little beat here I was going to play. Let me see. I want to make sure this isn't too loud before I start playing.
Why don't you play the 1X Developer main theme?
I don't have it on this computer, I don't think.
Yeah, it's okay.
Sorry. I just came up with this like little stupid beat. But hopefully you can see here he's kind of like it's responding to the kick, right?
Yeah, I don't hear it, but I see it.
Oh, you don't hear that audio?
No, I don't hear the kick. I heard the synth earlier. But I mean, I can imagine it from what I'm seeing. Yeah, I see the blinking light, so.
Yeah. Oh, dang. I don't know why that's not working. But yeah, imagine a steady kick there.
Yeah. Dude, our audio listeners right now are like, yo, this is awesome.
Sorry. You got to tune in and see the wizard. Yeah. So let's kind of like let's go through the code a little bit, and we'll talk about what's going on here.
Yeah.
So first thing you got to do is enable audio for your project. And that's like a project setting. So into project settings, audio, driver, and you got to enable input right here.
Okay. So
That's
that's what allows it to respond to outside audio, basically.
Yes. If you don't do that, yeah, you won't be able to do any of the audio input stuff. And I think that setting requires a restart if that trips you up. Then you have to go into down at the bottom here. There's this audio tab. You have to create a new bus. Well, didn't mean to do that, but you want to create a new bus and call it record. So you need a separate audio bus for your input that's separate from this master bus that's like where the audio from your game is coming out, right? So the master is your output. The record is going to be your input. Once you have, and then the other thing is that on that record bus, you want to do add effect and add a capture and a spectrum analyzer. These are two different ways of capturing audio. These correspond to the way that we were doing the light source on the magic ball and versus the beam. So we'll kind of like talk about those a little more when we get into the code. But you need one or the other. I only have both because I'm kind of like demoing, but there's nothing wrong with having both, but they're just like different ways of capturing audio.
There's a lot of effects in that dropdown.
Yeah.
It's a lot of stuff.
Those are all,
Cool.
these are all like built-in effects that you can do. And like really honestly with the ability to add buses and stuff so that the effects are only applied to specific buses is kind of, I mean, that's like really powerful.
Yeah, you could get really crazy with different filters and stuff if you wanted.
On top of that too, so you have those effects, but then some of the nodes that you can add here are for like audio, stream player 2D and 3D. Those work to like spatialize the sound automatically in relation to a position, right? So you get further away from the sound and it gets quieter, that kind of thing. You know, some of that logic's like already built into those nodes.
Right. That makes sense. That seems like a common game thing you'd want to do.
Yeah. Okay, so we enabled audio, we created a bus and added the capture and the spectrum analyzer effects to it. Next thing is you need in your Godot scene, you need an audio stream player. And you want to, for the bus, you want to point that to your record bus that you made. And you want to turn autoplay on so that it's always playing. Then within your GD script, so I'm just declaring a variable here that points to this audio stream player node. So just so I have a reference to it in code. Then
Can we maybe zoom in just a little bit more, make the font just a little bigger?
Yeah, for sure. Let me get rid of this audio thing now that we don't need that. Tell me when.
That's probably good.
Okay. So you have a variable that's pointing to the audio stream player. You have a variable that is you're creating a new instance of the audio stream microphone, and you do that. To be honest, I don't remember why I did the player as a node and the microphone in code, like why I'm creating that in code, but that's the way that worked for me. And so that's your input audio stream, and then you get the bus index for your record bus and your record audio bus.
Cool.
Then there's some variables here for the capture effect and the spectrum analyzer effect. If I remember right, there's something that prevents me from doing that all up here the same way, but like So I'm just declaring these variables here, and then in this ready node that runs when my scene initializes, that's where we're gonna set these. But these are just references to the effect nodes on the record bus. So
what does bus effect mean?
Bus effect is, so inside the bus itself, those are the references to our effects.
Okay, you're capturing your spectrum analyzer. Okay,
right. So each of those has an index within the bus. So up here, I found the index for the record bus, and then in here, I'm getting a reference to each of the effects that are on that bus.
Cool.
So 0 and 1. Kind of wish you could refer to them by name, and maybe there's a way to do that, but I'm just doing it by 0 and 1.
All right.
So there's this audio server object. Okay, so you got your audio stream player, got your audio stream microphone instance that you created. You have a reference to the bus index. You have a reference to each of the effects on the bus. And so there's this audio server kind of like singleton object that you use for a bunch of audio code. And to find your input device, you just do audio server get input device list. And you basically just have to loop over the devices that it lists and find the one you want by name. Seems like there should be kind of an easier way to do that, but that's the only way that I could figure out to do it.
Does seem like there's should be, but I guess that's fine. There shouldn't be that many devices.
No, most people wouldn't have more than 1 or 2 input devices, I wouldn't think. One of the other things I wanted to mention here that kind of tripped me up a little bit was it seems like Godot is limited to 2 channels of audio input. So like on my audio interface, I have 4 channels. It only listens to 1 and 2, which seems, I don't know if that's a big limitation or not. I mean, I guess most people for games are probably not doing like elaborate audio inputs. You know what I mean? They're just listening maybe for a microphone input.
Microphone, if anything.
So I think that's probably like the spirit of what's going on there. But I use a program called Loopback to like to combine audio streams basically. But I'm sure there's a lot of different ways to do that, and probably outside the scope of what we want to talk about here. But like you'll need to do, if you have audio from multiple sources, like I have my synthesizer and I have my thing that was playing the beat. I'm using Renoise for that. Like if you want to have input from multiple sources like that, you'll need some way to combine the audio inputs into like 2 channels.
Okay.
Yeah, I'm sure there's lots of ways to do that.
That does sound like it's probably more of a Brendan problem than a normal person.
Yeah. No, I think for most people, you're just going to have an audio interface, and you'll plug your whatever you want to respond to it into the audio interface. Bada bing, bada boom. So then once you found your device, so audio server get input device list, loop over the devices, find the device, and then audio server set input device to find the device. And that all happens every time the program starts. And then grab your reference to your audio stream player node that you had up here, set the stream to this microphone, audio stream microphone instance we created, and then you tell the player to play. And that's it.
Cool.
So that's the setup. So at that point, you should have audio coming into your application. Now, let's talk about like the 2 different effects here, the capture effect and the spectrum analyzer effect. We have a whole series of videos on like the basics of digital audio. So if you want to know more, check out our series there. What's it called? Just Introduction to Digital Audio?
An Introduction to Audio Programming.
Ah, okay. So a good chunk of that Introduction to Audio Programming was taken up talking about like the basics of digital audio and the way that digital audio is built up of samples. So if all this is like totally foreign to you, maybe that would be a good place to look for more info. But basically, you have two ways of doing this. The capture effect is giving you just your raw audio samples. So that's like, remember we talked about in digital audio, you have samples oscillating between -1 and 1, creating the waveform. That's what the capture effect is all about. It just gives you an array of floating point values between -1 and 1. And it's up to you to like do whatever you want to do with those.
Okay.
On the other hand, the spectrum analyzer effect uses the FFT, the fast Fourier transform, and it gives you a magnitude for a frequency range. So you tell it from, I got my range backwards here. You tell it from this frequency to this frequency, tell me the magnitude of that frequency range within the signal.
Right.
So that's the one where his magic ball is responding only to the bass, is because I'm using get magnitude for frequency range and only looking at the bass frequencies.
Cool.
I think, I don't know, these are both helpful, but they're both, very different ways of doing it. So let's do spectrum analyzer first. I think that's much easier to explain. I mean, it really is that easy. So you have your reference to the effect on the audio bus, and you just call get magnitude for frequency range, and you do your range. All I did here is it gives you one magnitude for the left channel, one for the right channel. I just averaged them together, and then this just sets the scale on the size of that light source that's growing and shrinking. Just sets the scale to that average times a frequency scale, which is one of my export variables, so that I can mess around with it.
Yeah.
You just need to just multiply it by something to make it fit whatever you want.
Cool.
The capture effect is a little bit more. There's a little bit more going on here. But basically what you do is you say get frames available, and one of the nice things is that Godot takes care of all of the complexity around, like, how do I say this? If you think about it, you're going to have a different number of audio frames to process depending on how fast your game is running, right? So like the number of audio frames that you have to process is dependent on your frames per second, I think. Does that make sense? Like, the more often you're running this process function, which runs, I think runs once per, every time you have a frame that needs to be drawn, this process function runs, and you use this,
like a built-in like Godot thing that does that, right?
Yeah. Yep. You don't need to worry too much about that. You just need to get frames available, and then I guess all I'm trying to say there is don't assume anything about the size of how many frames you have, right? You need to cycle through them and just process what's available, and don't assume that you're always going to have 1024 frames or 512 frames or whatever. So you get your frames. If you have frames, then the frames, you can get those the values directly with get buffer. And then I just pass those frames directly to this frame visualizer function. The frame visualizer is the beam coming out of his magic ball. And so when the component, or when the node initialized in Godot, we just went through and created 1,000 different like little, I forget what node type I used here. Oh, color rectangle. So these are just like a very simple colored rectangle, and there's 1,000 of them going off to the right. And then every time that we have audio frames available, we run this update beam, and we just go through, and basically what I did is I just took the absolute value, kind of scaled it, and then kind of like offset it so that it's like symmetrical up and down, you know what I mean? So you can see that in the beam, it's like totally symmetrical top and bottom.
Right. Yeah.
It would be, I guess it would look a lot more like a waveform if I didn't do that.
So what are you doing to make it do that?
I'm taking the absolute value. So instead of worrying about, so you have these values that are oscillating between negative values and positive values, right?
Oh yeah.
So I'm taking the absolute value and then just like scaling it, and then I'm moving the position. So every colored rectangle is, I make it like if my magnitude was this, I double it and then I move it down halfway.
Okay.
Does that make
Yeah.
sense?
Cool. Yeah, I see what you mean.
I'm sure it would look fine even if I didn't do that. I forget what I was trying to do there. But anyway, that's how I did that. But those are kind of the two, I mean, those are really the two like things that affect, or the two effects that you can use to analyze audio and respond to it. One is like within a frequency range, and the other is just the raw samples that you can kind of do whatever you want with.
I was wondering, like, have you heard of a game called Phasmophobia?
Mm-mm.
It's not. I think it's a Unity game. It's definitely not a Godot game. But it's a game where you're like you and your friends play as like ghost hunters, and so you're like in a haunted house, and you're trying to capture this ghost. It's been a while since I've played it. There's a lot to that game that I don't know, but I do know that there's some level of the ghosts like react to your voices in game chat. So like you actually have to whisper to each other like to not draw attention, and they react to certain words certain ways. Like if you say their names, I think that like makes them angry or something. But
that's really cool, actually.
Yeah, you should look up some videos. It's some of the stuff that happens is nuts. But I was while you're talking about that, I was wondering like when it comes to the determining if a player is whispering or if they're too loud, I wonder if they're doing that, just taking a magnitude of a spectrum analyzer or something similar to that.
Yeah. Oh yeah, I would assume that's exactly what they're doing. Just seeing if it's above a certain level.
Yeah, and there's a few games that do that where they react to like what the player's microphone is doing. I think I've seen some horror games where they like if you scream, it's like it can like detect that or something. But some of those gimmicks. But yeah, it's interesting to think that how they do that probably isn't really that hard, really, right?
Yeah, I mean, it can get kind of elaborate because I think what gets tricky is just tweaking and dialing in the right like kind of frequency ranges.
Right.
You probably, when it comes to like human speech and stuff, not all frequencies are created equal, basically.
Yeah. Especially if everyone's got different microphones and stuff.
Yeah. So there's probably they probably have some way of like detecting what normal speech sounds like on your system and then like adjust from there.
Yeah. Yeah, cool.
There's one other thing I haven't told you about my wizard, Colin.
Yeah.
Sometimes, hold on. Let's get some music playing first.
Okay.
So you can't hear that music, but you can see the wizard reacting?
Yeah, I see it, but I don't hear it.
Okay. That's fine. We'll play that for a minute. Let's see. Do that a little bit. All right. Check this out. Sometimes things get a little wild and my wizard gets mad.
Whoa. Well, did you do that or what triggered that?
I clicked a button.
Oh, okay. Oh, that's cool.
But my original plan was that he was going to have like a beat detection algorithm, and if the BPM got above a certain thing, he was like going to get all angry.
That would be cool. Yeah, that would be cool.
Yeah, I thought that was pretty fun.
I did want to ask about the scene. Like, so you have like a scene with a I forget the component name you said. It's the like audio analyzer thing.
Mm-hmm. The audio stream player.
Yeah, audio stream player. And so then the audio stream player has your scripts attached to it.
Yeah, let's take a look at my code here. So again, I want to stress that like this is just my first crack at this, so
Yeah.
I'm not claiming this is the best way to do it or anything like that. But what I have is my main scene. So in Godot, you have one main scene that's what gets launched when the game launches. My main scene has some lighting stuff. It has the background for the bricks. This is a scene for the wizard. That's my main wizard. I have the red light that turns on when he gets angry. I have the beam. This is some more lighting stuff. And then I have my audio stream player. So it is a direct descendant of my main scene.
Nice.
Yeah. And then the wizard is mostly just sprites, and the magic ball is its own thing. The little like magic going on inside the ball is actually some particle system stuff.
Oh yeah, how do those work?
Honestly, I kind of just experimented until I found something cool.
Yeah.
But the basic gist of it is that I have this texture, which is just a swirling circle. I don't know if you can see that, but I just animated it so it's like rotating constantly. And then the particle systems are just kind of these abstract textures. I don't know how if you can see that very well, but it's just like it's just kind of a small texture that has that's it. The particle system is generating one of those every whatever seconds, right? And then they kind of like fade out. And so hopefully with two different particle systems, they're generating different textures, and hopefully that keeps it interesting enough.
Yeah. It looks really good, I think.
Yeah, thanks. I mean, the particle system stuff is so deep. Like, all of these are like menus within submenus within submenus. So you can go crazy with it, and you really do have to sort of know a little bit what you're doing, because you want that stuff to process on the GPU. And so like, there's the node here is the GPU particle 2D. So I think that everything you do will always get executed on the GPU if you're using that node. But anyway, that's like a whole thing you have to learn about.
Yeah. Yeah, I'm sure there's probably good tutorials on that out there.
Yeah. Yep. But what were you asking about though, about the audio stream player node?
I just want to know what the setup was on the scene. That's something that I sometimes I feel like first of all, I feel like some tutorials kind of gloss over that, and I also feel like it's not always obvious. Like really, more so when you're making a game and you have different scenes, like different levels, like how that's managed is like not always obvious to me.
Oh yeah.
But so yeah, so and that just I mean the audio stream player you showed in the code how that just everything just kicks off on ready, so it's like it's just playing once you start the scene, right?
Right. That code that I was showing was actually part of my main node. So the main node references the audio stream player, which is its child. And you can, when something is an immediate child like that, well, so the $ is like a node reference. You're referencing a node object. And when it's a direct child of the node that the script is executing in, you can just reference it directly like that.
Okay, yeah. No, that's what I was asking. So then what's your wizard script? Is that animation stuff?
Yep. So I have some export variables here. So if I go to my wizard scene, you can see that these variables that I've exported are available over here on the right. And so each of these just has, when it changes, I set the animation speed. So I reference the animation player for the appropriate, like whatever value changed. Each of these has their own animation player, one for each hand, and then the head each have their own animation player. So you can control the speed of them independently.
Yeah, cool.
But that's the bulk of that. Nothing happens on ready with my wizard or on process. Yeah, no, I know what you mean about when you're saying about tutorials, kind of gloss over it and like best practices for organizing your Godot project, because there really are a lot of ways to do it. And actually, you can kind of see I have I'm doing multiple ways here. So I think Godot is pretty flexible in what you can do. But in my main script here, when so like when I go into Furious Wizard mode, these are just I'm just doing a tween, which is like an easing function. So I'm just saying like transition to a different color over the course of 1 second.
Yeah.
So that's one way to do it. But then like when in my process function, when I get the magnitude for the FFT, I'm referencing my main wizard node and then calling a function in the wizard script.
Yeah.
That's like another way to do it. And then a third way is that in my main script here, I've declared a signal that Furious Wizard mode has changed. And if I go over here to signals, in my wizard script, I have a function that's listening for the signal that gets fired off from my main script, and then he handles all of his own properties.
Cool. Okay.
So those are like 3 different ways to do a lot of the same stuff. So I think it's really like on you to keep your project organized. There's a lot of different ways to do it.
Right. Yeah. Well, and it's important. I mean, because when you're doing that stuff, the hierarchy in the scene view has to be right. You know, like the audio stream player has to be a child of main for that to work.
I mean, I think it could technically sit anywhere it wants to, as long as you reference it correctly in your script, right?
Yeah, but they're related. Like if you're doing it this way, then it has to be set up that way.
Yes.
Yeah.
Yeah, so you can reference like in the hierarchy, you can do I don't think I have any examples here, but you can reference like nodes within. I could reference my wizard is an instance of the wizard scene, and I could reference any of these nodes within the wizard by doing main wizard / whatever, you know?
Yeah.
Does that make sense?
Yeah.
So I think, you could put audio player somewhere else. Maybe if your project was like really, really complicated, maybe it makes sense to like consolidate those under their own node, so that if you had multiples, you would be able to like kind of put those off somewhere in their own collection. But for the way I have it, where I'm just referencing the node in the ready script of the main function, it needs to be a child of main.
Yeah, and I think that's the right way to do it. How do you like GD script?
It's not bad. I mean, if you know Python, it's cake.
Right. That's the selling point, right? Is it's basically Python. Yeah.
Very, very similar to Python. I don't know, a few differences. It has a little stronger support for types, which I kind of like. This assignment thing that I'm doing here is like it's basically automatically detecting the type, and then I would not be allowed to change the type going forward.
Yeah.
Which I kind of like. I mean, I would love if Python had a little stronger support for types myself.
Yeah.
But yeah, I think it's pretty cool. Signals are great. That's like a really cool thing to have like built into GD script. But other than that, yeah, man, other than a few keywords and stuff like that, it's pretty similar to Python.
Yeah, cool. Oh, this is cool. This is a good one.
Yeah. Hopefully that's helpful to somebody. Like I said, I kind of had trouble finding all that stuff in one place. It was a little, I don't know. It just seemed like it was scattered. I was surprised that I couldn't find a good all-in-one tutorial for that.
I think that is one of the minor complaints about Godot compared to some of the competitors, is that there's a little bit less community, like a little bit less information out there, but I think that's changing. I like Godot a lot because, I mean, it's open source, but also it's way less resources than like Unreal or Unity. It starts up really quick. That's the thing that always really annoyed me about Unity is like, first of all, it takes forever to start up, and then I have to log in. You like have to log in to use it. It's one of those.
That sucks.
And yeah, so Godot is cool for at least for me. Like I'm not really shipping games. I'm just like screwing around. I like it.
Yeah. No, my experience with like the program itself and the editor and all that has been really, really good. I think they did a fantastic job. Kind of like Blender. It's like, this is high enough quality that I kind of can't believe it's free and open source. You know what I mean?
1X Developer Podcast.
Hey everybody, this is Colin. First and foremost, I want to thank you all for listening to this episode of the 1X Developer Podcast, and let you know that if you have any questions, comments, or if you just want to tell us about your day, you can reach us at X, formerly known as Twitter, at 1X Developer Podcast. We're also on YouTube at 1X Developer Podcast. You can email us if you're weird at 1xdeveloperpodcast at protonmail.com. And lastly, don't forget to follow, subscribe, all that stuff, so you don't miss any further episodes of the 1X Developer Podcast. Thanks so much. See you next time.